Hello and welcome to another episode of Earth911 Sustainability in Your Ear. I'm Mitch Ratcliffe, your host, and we have another innovator interview today, and it's with Paul Bloom, who's the Vice President of Sustainable Materials at Archer Daniels Midland, or ADM, as many people know it. It's a food and ingredients processing company, and they've embraced a number of sustainable materials initiatives that we invited Paul on to talk about. Paul, how are you today?
Doing very well, Mitch, and thanks for having me.
Well, hey, we're glad to have you here. ADM does a lot of things that touch our lives, but many times it's pretty invisible to us. So I'd love to dig into where your consumer-friendly examples of what the bio-based solutions ADM develops touch our lives. Can you just kind of tell us first, how does ADM support the food system in the United States, and why are you moving into sustainable materials?
Yeah, sure. Great question. And like you mentioned earlier, we're a global leader in human and animal nutrition, and actually the world's premier agricultural origination and processing company. But we really provide the link between the grower and the ingredient customer. So you don't necessarily see us even at the grocery store on the labels, because we produce kind of and provide the ingredients that so many brands and products that people use every day. So, it's a little bit hard to see us there on the store shelf, but, in most of those products you see at the grocery store, they're there. And then, we end up in places that you don't think about us. A great example of that are in the cardboard boxes that show up more and more these days on our front porch from Amazon. Products like starch that we provide into the food and nutrition space also end up in, sustainable materials applications. So the adhesive actually in a lot of those corrugated boxes has always been starch. And it's a great example of how we're providing, sustainable and recycling technology into the market, and have for a long time.
Well, and it's important that that's a plant-based material, because that's recyclable as compared to a petrochemical adhesive. And so, and of course, there's so many more boxes coming to our homes. Now, what is your area of focus? Tell us about that.
Sure. So my area of focus, we've got really, and have since the company was founded in 1902, a whole portfolio of sustainable materials. So what does that mean? That means really plant-based biomaterials that are kind of broadly defined in a non-food space. So I really have this really fun job to work with our business groups who in our existing divisions. We have all these great products that come from nutrition, come from our carbohydrate solutions business, and come from our oil seeds that end up in many of these products that we touch every day that are on this non-food space. So I work with those groups, and then we also have a lot of new growth areas where we're creating new materials for packaging and for other material solutions, and even for things in personal care that are all plant-based and many biodegradable solutions that are new growth opportunities for us. So that's kind of a high level of where I spend most of my time, between the existing portfolios and on some of these new growth opportunities.
Well, let me ask, because sustainability is so new, how did you get involved in this as compared to, you were an engineer previously, as I understand it? Obviously.
Yeah, I'm actually a chemist by training, a high performance polymer chemist. And, it was one of those great opportunities that ADM had, since ADM had been into sustainable materials since the founding of the company. I really was brought into the R&D group and got to work on a lot of cool projects like, no VOC solvents and products for paints and coatings. So I really started in our R&D division, and then, continued to become more and more involved in not only the food products that we produce, but, in a growing presence that we had in looking at new and innovative products for our growth, and then really started to get involved on the commercial side when we scaled up a propylene glycol technology. And when we think about propylene glycol, if you're not familiar with the chemical industry, right? I'll try to
please explain, because everybody wants to know.
Yeah, I'll try to refrain from too much trimethyl chicken wire, and that won't be Professor Paul today. But propylene glycol is a chemical that we use that's traditionally derived from petroleum, and we saw this opportunity to instead make it from glycerin that was a co-product from our biodiesel operations. And so back in 2010, we scaled up a plant, and were able to provide the same functionality that you get from a petroleum product, but now just make it a bio-based product, but also have a 61% greenhouse gas reduction, right? So, I mean, those kind of projects really kind of solidified where I like to spend my time, and just thought it was fascinating, and it was a great opportunity for me personally. But it was really it's been a interesting project for ADM to get that up and off the ground, and be successful with that, and have built a business there today. Not an easy road, right? Not
no, there's nothing easy about this right now. But that's really interesting. A lot of people tend to think that there's sort of a linear product stream here, that you do one thing at a time. But as you just pointed out, the biodiesel process has additional outputs that you can create other products from. And so you're really kind of thinking about how to take the chemical or molecular basis of plants and turn them into everything. Is that a good way of characterizing it?
That is, right? I mean, what we want to do is take this great gift that nature has provided, right, and then use those resources in the best possible way to satisfy the demands that we have for our needs. And so I think the other thing to think about is a lot of the products that we produce also have dual use, right? So even propylene glycol is used in personal care products. It's used in food, but it's also used in things like fiberglass resins. So pretty interesting how we go forward with these. And if you look historically on our existing portfolio of materials that we sell, you see that similarity kind of across that portfolio, where things like vegetable oils, right? We can cook, we can fry, we can use them in salad dressings, but they also end up in pretty unique places, like in ag adjuvants, and to help with crop protection. And they also end up in things like tires to make them more sustainability, to improve their sustainability.
So what would you say is the most exciting thing that you're working on right now?
It's hard to say that we've got one that's the most exciting, right? I mean, part of it is just the interest and customer driven focus for sustainability today. That's very exciting, because we get a lot of calls on how can we help, and that's exactly, we always want to start with the customer in mind, and make sure that the solutions that we're providing are those ones that are being driven by the market, that really have value to the customer, and that we're serving these unmet needs. So there's just so many of those. And then when we think about kind of the new growth things, right? I'm an R&D guy by training. So I get excited about, what's the next big project that we've got. And, we've got a few of these that that we're working on, that we've announced. So we've got some new ones in the sustainable packaging area. So we've got a new molecule that we've produced from fructose, right? And as you know,
sugar.
Typically fructose is inside the bottle as a nutritive sweetener, but we're now being able to use this fructose to produce a molecule that can help reduce the amount of PET that would be required in a final package, specifically for carbonated beverages.
So reduce the amount of petrochemical-based plastics with a biochemical or bioplastic alternative.
You got it. And so it's really interesting, because you think about the bottle. If you compare, just think about the end application to start with. You get a bottle that's made for a carbonated beverage versus a bottle that you typically use for water, right? And the thing you notice first is that the carbonated beverage bottle is a lot thicker and more durable, right? But that's really because it needs to keep that carbonation in to maintain freshness and provide barrier properties. the solution that this molecule that we're making called FDCA or FDME that's derived from fructose, what this helps is in the polymer, it improves the barrier properties to keep the CO2 in and oxygen out. And it does that in such a way that then you can use less plastic, less PET overall to get to the same performance in that bottle. So you can maybe use 20, 30% less plastic to deliver the same solution and still be fully recyclable and, bio-based. So it's pretty cool.
I'm curious, does that mean that eventually that you don't need any oil-based plastic, or is it always going to require some oil-based plastic, do you think?
Yeah, I think this is one where, we really value partnering with, the traditional chemical industry to figure out what are the best solutions. I think most of the areas that we see is that we're not going to replace the chemical industry, but we're going to supplement that in the right ways where the solutions we bring to the table really fill an unmet need, like the one that we're talking about now. And, so I think there's a good fit between, how do you take a great plastic that provides a lot of safety and security in our food system today, like PET, and be able to use less of it, make it better with really more of an additive approach that we can develop from a plant-based solution and still be fully recyclable, which of course, we've got some work to do on the recycling front to make sure we collect and make sure those things don't end up in a landfill. But if we can put all that together, then I think we've got a winning solution that, as you move towards a circular economy, you can continue to recycle these things more and then use mechanical recycling, use chemical recycling, but then combine the best of both from the industries to give consumers the most sustainable solutions.
Well, and of course, we do need to increase our recycling rates for plastic, which are around 8%. But, the fact that it is bio-based and recyclable, I think is one of the incentives that people are looking for, to know that they're not simply supporting the use of more oil-based plastic. Now, let me ask about another thing that stood out for me when we were doing our research, and that is you're working on materials to make sustainable diapers. Does that mean that diapers will be compostable someday, or will they be recyclable?
Yeah, no, great question. And, probably the answer is it could be both, right?
Really?
But today, the program that we're working on, and it's another great partnership that we've developed with LG Chem, obviously one of the leading petrochemical companies in the world, but they have great sustainability goals. Last year we announced that we really wanted to target the acrylic acid market, and much like what we've done in propylene glycol, focus first on saying, look, there's a whole industry out there that uses acrylic acid today. Mm-hmm. Part of that goes into the super absorbent that's used in diapers. Part of it goes into coatings that protect our homes, protect our cars, and for years and years in the coating space. And if we can make that from a bio-based source, we can decrease the greenhouse gas emissions and increase the biogenic carbon that is basically sequestered in these products. And so that's kind of step one. Mm-hmm. And then we get to retain that performance. We get to use the capital that's already in the ground and the great applications and performance that people expect today from their products. So that's really the program that we've started. We also have, which will be longer term, but we've looked at these where we have starch-based super absorbents that are biodegradable. Now, the previous material that I talked about, the bioacrylic acid is going to be the same acrylic polymers that are out there today, just with the bio-based carbon. So they're not biodegradable. But the materials that are made from starch, they offer a lot of promise long-term for being compostable, for being biodegradable. But, today what we've found, and we've worked on this for quite some time, is that the performance isn't quite there. And things like in diapers, one of the key metrics there is called absorption under load, which I don't think needs a whole lot of explanation.
No, but, I think we all get it.
Yeah, but that one, we haven't been able to get the starch materials up to the same performance as what we would typically expect from an acrylic-based superabsorbent polymer. But that doesn't mean we're not going to continue to try and work on that and keep making progress there.
Oh, Elon Musk's rocket exploded on the launch pad yesterday. He's going to keep at it. So will you.
That's right. We're going to keep working with this. And for us, it's a little bit about horizons, right? Mm-hmm. So, what can we do first? How can we make a big impact? And then what's the next horizon? We know this isn't going to happen overnight, and this is a journey. And like I said, we've been on this journey since 1902. I mean, really, it's interesting when you think about ADM. We started with flax and linseed oil, and all of the products in 1902 that we made went into paints, coatings, sealants, adhesives, and even things like linoleum flooring, which were all renewable even in 1902. So we have a long history in this, and so we think about it for the long term, and just like we're doing on the nutrition side, sustainability is really baked into everything that we're doing at the business level.
So how's demand for renewable and plant-based materials changed during 2020 with the pandemic and our new awareness of how fragile every aspect of our supply chain and economy can be?
Yeah, great question. And I was definitely concerned. We saw at the end of last year, right in September, we had climate protests, and you definitely saw single-use plastics being part of that. And obviously with COVID hitting, and I think even from some of your earlier podcasts talking about the extra demand for plastics and even single-use plastics in COVID, I mean, that's, we've seen more demand for some of these materials and plastics. So, but I think the good news is that, just like COVID has heightened our senses for, okay, look, we need to be prepared. We need to think about what can we do to protect our health. Part of that is also, we see more consumers thinking about what do we need to do to protect our environment, and the link between environment and their own personal health, I think, has only gotten stronger from, going through this whole pandemic. So I think, from some of our research, I think we see like 65% of the consumers who would really say, look, we want to get more sustainable solutions. We want to purchase more sustainable solutions. And probably 71% of those that we've surveyed said that, what really appeals to them are plant-based solutions.
Right.
And so, I think it's a really positive thing. And I think once we're done with the current pandemic, we'll get back to the plastics pandemic, or, and think about, what are the other things that we need to do, because some of the time horizons that we need to make changes and address are upon us, well past being upon us.
So for our listeners who are thinking, well, how can I make a decision today that is a little more sustainable? You mentioned FDME, the fructose-based bioplastic earlier. Can you identify that when you're at the store today? What would you
I should have. It's a great question. I should have mentioned it earlier. I mean, that one is one that's not there today yet. I mean, it's still at the research stage.
Okay, what's an example of one that is?
Yeah, so some of the ones that are, so you can think about that propylene glycol business that I talked about launching back in 2010. So when you see things like propylene glycol on the label, which will be part of the ingredient list, that's a good example. Some products that also, will carry a plant-based label on them, they may not necessarily be called out as, saying that the propylene glycol would be from ADM, for example, but right. You'll see that made with plant-based products on the label. I think another good place to go for consumers is the Plant-Based Products Council, which is a fairly new group, but PBPC is the organization, and they've got a lot of really good consumer information on their website, and continue to do good consumer research to help customers really make good choices on these. Because again, most of the products, you even think about, I'm confident that people a lot of the listeners today have probably touched some of the bio-based materials that they don't even know they used today, things like sorbitol in toothpaste, right? I mean, sorbitol by default is going to be a bio-based product that gets used ubiquitously in personal care products. So, you know, we've got a lot of good examples like that you probably don't even realize.
Well, so let me turn to the question of ADM sustainability goals. You have set goals for 2035 that include reducing greenhouse gas emissions by 25%, reducing energy intensity in the product by 15%, and reducing water usage per ton of production by 10%, as well as having at least 90% of the waste that you create being reused, recycled, or otherwise diverted and out of landfills. These are not quite as aggressive as other organizations, and yet I also heard you say earlier that you could reduce with FDME the CO2 output by up to 60%. What's the thinking about how fast ADM can get to a net zero system?
Yeah, again, great question. You know, I think the way we think about it, Mitch, is that we always think about setting goals first that are smart goals, right? That are specific, measurable, achievable, realistic, and time bound. And we do that kind of across the board for everything that we do in our goal setting process. And as we thought about the Strive 35, right, what we're going to do by 2035, you know, it was really built from a set and a nice study that we worked with the third party WSP Global to figure out what's feasible and what's achievable, right? Back to going to make these smart. So if you want to see the study, it's actually posted. We can get you a link to put on there, but it's on the website. So one thing we really value is transparency. And so when we thought these, we said, let's make goals that get us, you know, on this path that are still very aggressive, that we think we can make good on by 2035. And these are actually on top of the goals that we had. We had 15 by 20 goals, which were 15% reductions in each of these categories that we achieved a little ahead of schedule by 2020.
So when you go down by 25% in greenhouse emissions, for instance, that actually is a net of about 40%?
Yeah, I mean, that would be on top of that GHG emission of 25% is against our 2019 baseline.
Okay.
Right. So it's, you know, for us, it's a continuing journey. And, you know, so we think about it as, you know, how can we do this and still, you know, kind of make good on what we think is achievable. And, you know, so I think that's really the key for us. And some of these numbers are pretty big, right? So even in our 15 by 20, I was involved with a few of the projects that, just to give you an example on the water savings, you know, we work with a lot of partners on this, and one of our partners, we made a announcement, and you know, our water savings at that point back in 2018, 2019, we were able to save 2.3 billion gallons of water per year from the hard work that the team did and the innovation that was created. And, you know, just to give you an idea, that's about the equivalent of water that 8 million people would use in a year. So
when you say you saved it, did it go back into nature, or is it just simply being reused?
Yeah, so this was water that we just reduced that water intensity, right? So,
okay, so your intake decreased by that.
Yep. Yeah.
Okay.
Yep. So we do both, right? And when we do a lot of work on water and take it very, very seriously. So it's a key thing for us to continue to do. And, you know, like the greenhouse gas emissions, right? We continue to look at stuff. We've got some pretty unique programs that many people don't realize, like our carbon capture and storage program that's in Decatur, Illinois, where we're actually able to not just take CO2 out of the atmosphere, but we're able to capture biogenic CO2 and sequester that in a deep saline aquifer. And last year, I think we did about 500,000 metric tons, and in total, since the project started, we've done probably 2.5 million metric tons of CO2 sequestration. So a pretty big sequestration project And again, this is all CO2 that plants have taken in, they fixed. We're basically removing that from our fermentation processes, which is fairly clean CO2
Okay.
to
So
capture.
you're scrubbing the emissions from the process.
That is correct. That's correct. And this, we think, is a pretty unique way to go because, as we make products, from fermentation with microbial solutions, we can continue to capture CO2 as microorganisms produce new materials in fermentation. They usually give off CO2, and again, that CO2 is going to be a net zero already in the carbon cycle because it's bio-based CO2. But we can capture that and then sequester it in the deep saline aquifer, and so it's just exciting, right? Those kind of things to make a big impact. Not only are we using fermentation and bio-based chemicals, or making bio-based alternatives to traditional chemicals, but we can do it in a sustainable way.
So would a technology like that also become an ADM product that you could sell to other companies that, like breweries that do fermentation to create their products?
Yeah, it could. I mean, part of that technology, you really have to think about the geological formation. So we did a lot of work with partners to make sure, and we still do, to make sure that when we use and sequester and store the CO2, that it stays where it should. And but it's a 7,800 foot deep saline aquifer where that gets stored. So you do need somewhat the geological formation on the site to be able to do that, but it's definitely an area that we continue to investigate.
Well, hey, Paul, this has been a great conversation. I want to thank you. And I'd actually probably like to have you come back and talk a lot more about carbon sequestration because we covered that extensively. But it's been a pleasure to talk with you.
Yeah, great, Mitch. Love your show and look forward to coming back.
Well, thank you. Folks, that's Paul Bloom. He's the Vice President of Sustainable Materials at ADM, or Archer Daniels Midland. And we encourage you to check it out. We'll also offer the link to the sustainability report that Paul mentioned in the article that goes with this podcast. So this is Earth911, Sustainability in Your Ear. And we hope that you will take some time to share the podcast with your friends because, sustainability is a community effort. It isn't just one of us making a change. All of us need to make this change. So take care of yourself, take care of one another, and take care of the planet. We'll be back soon with another show.